right, our objective today is I will solve area problems using the strategy find a pattern. All right, guys, we know that area is the number of square units needed to cover the inside of a figure, okay? And so we are going to use area today to solve word problems, and we are going to use a graphic organizer to help us be able to solve these problems. All right, so let's first unlock the problem, okay? As you can see already, this word problem looks like a lot, so definitely let's first start out reading it one time through, and then we're going to go back and dig a little deeper. It says, Mr. Coy wants to build storage buildings. So he drew plans for the buildings, okay? He wants to know how the areas of the buildings are related. How does the area change from the area of building A to the area of building B? How does the area change from the area of building C to the area of building D? All right, so there's a lot going on. But remember, first we have to make sure we understand the problem. And again, we know some guy, Mr. Coy, he wants to build storage buildings. Here are his storage buildings out to the side, okay? Right here. And they're labeled A, B, C, and D. Okay, so those are his storage buildings. He wants to know how the areas of the buildings are related. How are they alike? How are they different, you guys? Okay? And we know exactly, we're going to figure out how does the area change from the area of building A to the building B. So look here. As you can see, here's area A, and then here's area B. We want to know how these two are related. How do they change? We also want to do the same thing for how does the area change from the area of building C to the area of building D. Okay? And they're side by side. And again, we're going to use a graphic organizer to help us solve this problem. All right, so first, what do I need to know? I need to figure out find how the areas will change from A to B and from C to D. That's what the word problem said. And what information do I need to use? Well, boys and girls, if we are figuring out how the areas of these buildings are related, we need to use the length and the width of those buildings that he drew of each building to find its area, okay? So we're definitely going to use that. And then how will we use this information? Well, we're going to look at these storage buildings, look at the length and width, and we're going to record. That means we're going to write the areas in a table. And after we write everything in a table, boys and girls, we will be able to go back and look for a pattern to see how the areas will change, because that's what we're focused on. How are these areas changing? Now, the graphic organizer that we're going to use is a table, and this table is going to help us solve the problem, figure out the patterns, and it also helps us to organize our thoughts, our thinking, boys and girls. All right, so let's look. So right now we're just going to record. We're going to write the information that we know according to the storage buildings, okay? So first we're going to start with buildings A and B. All right, we know, let's go back and look at buildings A. The length, how long it is, this side is 3 feet, okay? And the width, how wide building A is 4 feet. So let me just write that information here in the table. And that's for building A, boys and girls. The length, how long it is 3 feet. The width, how wide is 4 feet. Well, let's look at building B. Again, the length, is 3 feet, as you can see right here. Well, let's look at the width. How wide this building is, and that is 8 feet. So let's write that down here. Okay, and that's for building B. Now, to find area, boys and girls, remember we learned we can count the square units, the number of square units needed to cover the inside of these figures of Mr. Coy's buildings. We can use repeated addition, but I'm going to use multiplication. All right, so let's see. Multiplication, we can multiply the length times the width, and we will get our answer. You could double check by going back and counting the square units. All right, so I know for figure A, building A, 3 feet times 4 feet is 12 feet. So that's the area, 12 square feet. Not just 12 feet, it's 12 square feet, because these are unit squares. Okay? So for building A, area is 12 square feet. Now let's do the same thing for building B. We're going to multiply the length times width. Length is 3 feet times the width is 8 feet. And 3 times 8, boys and girls, is 24. So the area for building B is 24 square feet. And I'm abbreviating square, as you can see, with SQ. Now, let's go ahead and let's compare building C and building D. Well, let's look at the length for building C. So let's look at C. As you can see, the length for C is 6 feet. I'm going to write that down here in my table, 6 feet. And then we know the width, how wide it is 4 feet. Okay, and they already have that here. Let's look at building D. The length of building D, boys and girls, the length is 6 feet, and the width is 8 feet. So I'm going to write 6 feet here, and they already have the width for us, 8 feet. So let's find our area. Well, building C, to find area, is length times width. So 6 feet times 4 feet is 24. So the area is 24 square feet. And then let's look at building D. Length times width, 6 feet times 8 feet equals 48. So the area of building D would be 48 square feet. Now, and again, boys and girls, you can use your multiplication, multiply the length times the width to figure out the area. You can also go back and count all of your square units inside the figure to make sure your area, to figure out your area, and double check your multiplication too. All right, so now that we use this information up here, and all we did, boys and girls, was write the information, the length and the width of buildings A, B, C, and D, and we just put it into a table because it helps us to organize our thinking. We really get, when it's side by side, we get to really look at the information. Now, what do we notice? Well, let's look at the lengths of each building. Boys and girls, in building A and B, look at the lengths, how they stay the same. 3 feet here, 3 feet here. Okay? However, look at the widths for building A and B. The widths of these buildings, they are doubled. In building A, the width is 4 feet, but in building B, it's 8 feet. It was doubled. Remember, doubled, think about 4 times 2 equals 8. And look at C, the same thing is happening. Look at the length stayed the same. 6 feet and 6 feet for building C and D are the same, but look at the width. The width also has been doubled. In building C, it starts out with 4 feet, and then in building D, it has a width of 8 feet. So 8 feet, it was doubled. 4 times 2 equals 8. All right, so I see that the lengths will be the same and the widths will be doubled. Now, let's really focus on the area, okay? The areas, look here, look at A and B. Well, the area for building A is 12 square feet. Well, look at the area for building B is 24 square feet. So the area was doubled. It was also doubled over here. Look at building C, the area is 24 square feet. Building D, the area is 48 square feet. That was doubled. So let's plug this information in. The areas will change from 12 square feet, and that's building A, to 24 square feet of building B. And let's look at building C, and from 24 square feet to 48 square feet, and that's building D. So when the lengths are the same and the widths are doubled, the areas will also be doubled. Okay, let's look at another example. Let's do one more. Now let's say Mr. Coy is building more storage buildings. He wants to know how the areas of the buildings are related, just like our first example, boys and girls. How does the area change from the area of building E to the area of building F? So here's building E to building F, and then we need to figure out how does the area change from the area of building G to the area of building H, right here. So here's E, comparing E to F, and building G to H. And again, we're going to use a graphic organizer, which is the table, to help us organize our thoughts. All right, so let's, what do I need to find? Boys and girls, again, we just said we need to find how the areas will change from buildings E to F and buildings G to H. What information do I need to use? Well, we need to use the length and the width of each building, of each rectangle, okay? And then how will I use this information? We're going to write in a chart, or we could say a table. And then after we write all of our information in the table, we'll be able to look for a pattern to see how the areas will change. All right, let's start with building E and building F. Let's look at the length. How long? Building E is 5 feet and the width is 8 feet. So building E, 5 feet, and the width is, I said 8 feet. Let's look at the length and the width for building F. Okay, building F has a length of 5 feet also and a width of 4 feet. 5 feet by 4 feet. Okay, and I just took that information from these buildings, from the rectangles. Now let's figure out the area. I know that area is length times width. All you have to multiply are these sides, or you can use repeated addition or count by ones all of the unit squares. I'm going to use my knowledge of multiplication facts. For E, the area would be 5 times 8, and that is 40. And it would really be, how I would write the area is 40 square feet. And let's figure out area for building F. Again, you multiply the side lengths, length times width. 5 times 4 is 20. So the area would be, for building F, 20 square feet. Okay, let's do the same thing for buildings G and H. Let's figure out the length and the width for building G. The length is 10 feet and the width is 8 feet. Let me write that in my chart. 10 feet by 8 feet. And then for building H, the length is 10 feet by 4 feet. 10 feet by 4 feet. 10 feet, and I'm just recording it here in the chart, by 5 feet. Now let's figure out the area for building G. Okay, all you have to do is multiply the two sides. 10 feet times 8 feet equals 80. So the area for G is 80 square feet. And then let's do the same thing for H. Find the area. Multiply the length times the width. 10 times 4 is 40. So 40 square feet. All right, so let's check it out. Now that we wrote for all of the buildings, we wrote their lengths and the widths, and then we multiplied to find the area. All right, so let's compare. It looks like, let's look at building E and F. In building E and F, their length stays the same. Lengths stay the same. But this time, boys and girls, let's check out the width. And remember, I'm writing this because that's what the word problem said. It says, how does the area change from areas E to F and the areas from building G to H? So you have to write your answer this time. But look at the widths, boys and girls. In building A, the width is 8 feet, but in building F, the width is 4 feet. So it's the opposite of doubling. It was halved. Think about halving 8. If you half, what's half of 8? And that's 4, right? So think of, it was halved. Halved, excuse me. So the widths were halved. Again, because what's half of 8? And that's 4. And look at buildings G and H. Again, the length stayed the same. 10 feet and 10 feet, those are the same. But look at the width for building G compared to building H. The width here, I'm sorry, this should be 4. The width here was 8 feet. And now in building H, it was 4 feet. So again, what's half of 8, you guys? Half of 8 is 4. So they were halved. So it looks like if the lengths stay the same, but the widths were halved, let's look at the areas. The areas, let's see, this time in building E was 40. Now in building F, the area is 20. So that's also halved. And then look at buildings G and H. G, the area is 80. And H, the area is 40. So those were halved. So if the lengths stay the same, but the widths were halved, the areas, boys and girls, are also halved. Okay, so today we solved some word problems. We used a graphic organizer, a table, to help us write our information down. After we wrote all of our information down, we were able to see what kind of patterns we had.